Hello students, in this video we will be discussing Standard Level Mathematics, May 2018, Time Zone 2, Paper 1, Question 10. This question is on functions in calculus. In particular, we'll be talking about the gradient function and the tangent to a curve at certain values of x. This is a rather long question, so we should look at it part by part. Let us start with the first. Consider a function f, the line L1 with the equation y equals to 3x plus 1 is a tangent to the curve of f when x equals to 2. Write down the value of f prime 2 and find f2. So before we start, we need to establish certain prior knowledge on function, calculus, and as mentioned, the gradient function and the tangent. So in our studies, we would have learned that for a given curve, any curve, at a certain point x equals to a certain value, you can draw a tangent line, which is a straight line, tangent, and that tangent will follow the straight line equation of y equals to mx plus c. And this point will have a given x. So in our question, we are given that the equation of the tangent is y equals to 3x plus 1, which means that the gradient is 3. All right, and we should write down for our answers. Part A, part 1, f prime 2 would be the gradient of the tangent. At the point. And the gradient of the tangent, this point is x equals to 2. So the gradient of this tangent would be the value for f prime 2. And we have completed part 1. All right. And part 2 asks us to find the value of f2. Now, we need to know that f2 is on the curve. But at the point when x equals to 2, this point is also on the tangent. So we can substitute the value of x equals to 2 into the equation of the tangent like this. And we should show our working to show that we understand that this is a common point. And this will give us the value 7. There you go, part A is done. Let us look at part B. So for part B, there's a function gx, and gx can be expressed in terms of fx by f of x squared plus 1. And P is the point on the graph of G, where x is equals to 1. So we should show that the gradient of G is 6 at P, and P is x equals to 1. And next, part C, we want to find L2, which is a tangent to the graph G at P. L1, the previous tangent, will intersect L2 at point Q. So we're supposed to find the coordinates of their intersection. Again, let's do part by part. Let's do part B first. So for part B, we know that gx is f to the x squared plus 1. We also know from chain rule that g prime would be f prime multiplied by the derivative this 2x is the derivative of x squared plus 1. This is chain rule. All right. And we also know that at P, x is equals to 1. So in other words, if we substitute x equals to 1, we will be able to do that across the whole equation like this. order x is equals to 1. So we realize the expression gives us f prime 2. 2 times 1 is 2. And we already know f prime 2 from our previous question, and that is 3. And we have shown that f prime g prime is 6. All right. Next, let's do part C. Since we know that at P, we want to find the tangent to the graph G. Let us do that. L2 is tangent to G at x equals to 1. This is point P. Right? So the gradient will be G prime of 1, which we have found and shown is 6. Okay. And we know that we can find G from evaluating f in certain way. So P is 1, 7. Okay. So in order to find the straight line, which is the tangent, P can do this. All right. Then we can proceed to find the coordinates of Q. So let's write down L1 is y equals to 3x plus 1. And L2, y equals to 6x plus 1. Let's call them equations. And solve simultaneously. Since the subjects are both y, we can say 1 is equals to 2. Right. 3x plus 1 is 6x plus 1. X is 0, x is 0. Substitute. There you go. We finished the question.